Another type of transformation is what is called a rotation. We're going to look at rotations today. A rotation will take every point and turn it through a specific counterclockwise angle. After a rotation, the shape is still congruent. It's just at a different direction and in a different orientation. We're going to focus mainly on three main rotations: a 90 degrees clockwise rotation, a 180 degree rotation, and a 270 degrees counterclockwise rotation. When we rotate 90 degrees, the point is going to change from xy to negative yx. They switch places and the y becomes negative on a 90 degree rotation. When we rotate 180 degrees, it's going to be negative x, negative y. You'll notice that's exactly the same as a reflection over both the x and y axis. So you might say that is a rotation in quotes. A rotation of 180 degrees is exactly the same as a reflection over both the x and y axes. To rotate 270 degrees, the coordinates switch places again, but with 270, the x-coordinate becomes the negative 1. So we're going to take a look at an example and see if we can do a rotation using these properties. So here we have a kite, and it is going to rotate 90 degrees counterclockwise, and then we're going to also do a translation 3 units to the right and 2 units up. So first we need to know where all the vertices are. So let's name this kite. We'll just name it A, B, C, D. So A is at the point negative 5, 4. B is at the point negative 1, 4. C is at the point 0, 2. And D is at the point negative 2, 1. And the first thing we're going to do is do a 90 degree counterclockwise turn. And what 90 degrees counterclockwise, first it's going to switch the coordinates, and then remember the 90 degrees is going to make the y coordinates negative, or take the opposite of all the y coordinates. And so when I do that, the y-coordinate was 4. This is the one we're going to focus on. The 4 now is going to become a negative 4, and then the negative 5 comes second. They switch orders, and the y becomes negative. So the 4 becomes negative 4, and the negative 1 stays the same. It's just coming second. Again, the 2 becomes the opposite, negative 2, and the 0 stays the same. Negative 2, 1 becomes negative 1, comma, and the x-coordinate stays the same, negative 2. But that's not the entire rotation, because it also wanted to go 3 units right. So we're going to have to add 3 to the x-coordinate, because that's what moves us to the right, remembering translations, and 2 units up. To move up, we add 2 units. And so we'll end up with a new image for each of these points. So for the x, we're going to add 3. Negative 4 plus 3 is negative 1. For the second x, negative 4 plus 3 is negative 1. For the third x, negative 2 plus 3 is positive 1. And for the final x, negative 1 plus 3 is 2. On the y-coordinates, we want to go 2 units up. So we're going to add 2 to the negative 5. Negative 5 plus 2 is negative 3. Negative 1 plus 2 is 1. 0 plus 2 is 2. And negative 2 plus 2 is 0. And now we have our new image, A prime, B prime, C prime, and D prime. We could also add a reflection to this if we wanted to and reflect the points. We can combine these transformations in any way we would like. But we're going to stop here and actually graph this new image. And I'll just go ahead and graph it in purple. A prime is at negative 1, negative 3. B prime is at negative 1, 1. C prime is at 1, 2. I'm going to move that B prime so it's not going to be blocked. And d prime is at 2, 0. And notice when we connect the dots, we end up with the exact same shape. It's just been rotated 90 degrees. And it's moved 3 units to the right and 2 units up. So that's our rotations. We should be able to learn really quick that rotating 90 degrees is negative yx, rotating 180 degrees is negative x, negative y, and rotating 270 degrees is y, negative x. Take a look at the homework assignment, try some of these rotations out, and let your instructor know if you have any questions.